Hi, good morning. My name is Jubina Kaituna. This video is all about research analysis technique from the study of Lucia Sisa, Nicolas Pedrini, Nora Altair, and Eduardo Abrio, entitled Alkane Priming of Loberia bassiana strains to improve biocontrol of the red-banded stink bugs, scientifically known as Isodorius guildini, and the bronze bug, scientifically known as Thomastochorus peregrinus. The research used a variety of techniques to analyze the effect of hydrocarbon nutrition and the virulence of Loberia bassiana strains against two insect pests. So, first, let me discuss to you what is alkane priming. So, alkane priming refers to the process of exposing fungal entomopathogens to specific alkanes before they are used to control insect pests. The mechanism, the alkanes act as a primer for the fungus, triggering changes in the fungus gene expression. This results in increased production of enzymes and protein that are important for hydrocarbon assimilation. Dito sa hydrocarbon assimilation, ang fungus become better of breaking down and utilizing the alkane found in the insect cuticle. Ito na po dahil sa cuticle degradation, the fungus produces more enzyme that can degrade the insect cuticle. So, iyang gubaw ng cuticle sa insect para musulod siya, allowing it to penetrate and infect the insect. So, ma-infect ang insect. So, stress tolerance, the fungus becomes more resistant to environment stresses it might be encountered within the insect bodies. The outcome, the alkane priming can lead to increased virulence of fungus against certain insect pests. This means that the fungus becomes more effective of killing insect. Here's the breakdown of the research analysis technique used. First is the pathogenicity and the virulence assays. So, the researchers tested the ability of Loberia bassiana isolates to kill these two insect pests. They did this by exposing the insect to a spore suspension of the fungus and monitor their survival over time.
Two different methods used to assess the virulence of a pathogen in insect pest. MLT is used for T. peregrinus, while SEM is used for P. guildini. This suggests that the virulence of the pathogen in T. peregrinus is more easily measured by MLT, while the virulence of the pathogen in P. guildini is more accurately measured by SEM.
Hello ma'am, my name is Argio Prospero. I'm going to discuss about the vegetative growth evolution. So, the researcher tested the ability of B. bassiana isolates to grow in different hydrocarbon substrates. So, ang researcher, ma'am, check nila if ang B. bassiana fungus, pwede ba siya mag-grow using the different types of hydrocarbons. They measure the diameter of fungal colony after 6 days of growth in the minimal media or MM experimented with the different alkanes as is well complete media. So, ilagi na measure kung unsa gid kadako ang fungal colony after 6 days on the basic nutrient mix.
Gene expressions analysis using qRT-PCR. The researchers use quantitative real-time polymerase chain reaction to measure the expression levels of 10 genes related to infection and B. bassiana. They compared the gene expression levels in B. bassiana grown on CM and MM supplemented with N-pendimethalin. This allowed them to see how hydrocarbon nutrition affected the expression of genes involved in hydrocarbon assimilation, chemical degradation, and oxidative stress tolerance.
Virulence enhancement and evolution. So ang purpose na is the evolution was to determine if growing Loberia bassiana strains on the pedipecane on the hydrocarbon enhance their virulence against two insect pests by comparing the virulence of this hydrocarbon growth traits to those grown at standard medium.
In summary, the research used a combination of biological assay, growth experiment, and analysis to understand how hydrocarbon nutrients affect the virulence of B. bassiana strains against insect pests.